Well, what do you think? Should I start? I guess I will. Hi, I'm Barbara Ekman from Comcast. I'm going to talk about Avro and Atlas and how we're using them in a big data project to do data governance and schema governance. And I want to make the point that I was here last year as a participant, my first actually time coming to this conference, and I spent a lot of the time at the conference as well as outside beforehand researching and trying to figure out which data governance tool to use. And what we decided on is Apache Atlas, and it has worked really well. So it's exciting to be here to be able to talk about what we did. So the mission of the group that I'm in, it's called DEEP, the Data Engineering and Analysis Platform, is to gather, organize, make sense of Comcast data, make it universally acceptable through platforms, acceptable, yeah, hopefully, and also accessible through platform solutions and products. And this is just to remind you how big Comcast is. Dozens of stakeholders, dozens of tenants, tens of petabytes of long-term storage, tens of millions of customers, hundreds of millions of devices, thousands of cores of distributed compute. So this is big data. So here's my motivating example. I hope this is not too hard to read. Say we're dealing with a record that represents a download session from an IP video player. So it has things like the time that the download session was created. Now these are in the number of fragments that are involved in the download, the device that the download came from or to, rather, the customer account ID, who was viewing it, and then the asset itself, the movie, the TV show, or whatever. Interesting data, right? And say we want to make it even more interesting by integrating it with customer experience data. So things like how many outages did the customer experience in the month, how many truck rolls, technician visits occurred to that customer, what their level of satisfaction with Comcast is, any number of things. Or we want to join it with analytics session information about latency and buffering. So then we would join on the device and the asset. The asset is the movie or whatever. And then if we wanted to join it on network traffic data, we would join on the device. Okay, that sounds easy, right? But we are dealing with a data integration shop of horrors. We have at least 3 customer IDs, several device IDs, and a ton of asset IDs, all for the same assets given by different groups. And everybody thinks there's this one called the media GUID, one ID to rule them all. That person was really an optimist. So just tons of different IDs for the same things. So data and schema governance to the rescue. So the questions that schema governance answer, and by the way, I should say this data and schema governance is primarily about making data integratable down the line for analysts to be able to make to ask questions of integrated data across silos that really address business critical issues. So it's not the kind of data governance, which is also very important, where you can be sure to be able to retrieve the email that happened on a certain date to be compliant with SARbox or something. That's another kind of data governance that is not what I'm going to be talking about. So the questions are, I want to join my data with your data, but what the heck does your data mean anyway? Is it safe to join my data with yours? Is my device ID the same as yours? And I don't want to create Franken-data that's like a monstrous chimera of data with 2 halves that don't match. What attributes in your attributes match mine? Can I change my schema without breaking systems of others that rely on it? Some data governance questions. Where can I find data about X? Data discovery. And how was it structured and who produced it? And then data lineage questions. How has the data changed in its journey from ingest, in our case, usually through Kafka, to where I'm viewing it? And if you're a consumer of the data, say in a data lake, if you're a producer, you want to know, okay, I published this data to Kafka, but where did it go? Where is it in the data lake or in NoSQL or other places? What happened to my data? Well, who's using it? So the outline of the talk will be, first I want to talk a little bit about Avro, how we use Avro, and what our best practices to make Avro even stronger. And then data governance using Atlas. Metadata browsing, we made some extensions to Atlas, both to the source code and to the type defs and the like, and then show how our platforms and Atlas work together to do data lineage. So who knows about Avro here? Almost everybody. So I'm going to skim through these fairly quickly. For those who don't know, it's a schema language, basically. It's in JSON. It's also a compact serialized format. It has APIs in a bunch of languages like C, C++, Go, Python, Java. I'm sure I'm forgetting something, but tons of languages. And its benefits are it provides cross-language support for dynamic data access. This is in distinction to things like protobuf and thrift, which have their uses and are very powerful, but they're not really dynamic. And there's a simple but expressive schema definition language for schema definition and evolution. Types, you have the typical primitives, some complex types, and then my personal favorite, the enum type, where you say it's either Larry or Mo or Curly, but unfortunately not Shimp. No New Jerseyans in this audience? Man, Three Stooges. Okay. So a simple example, we have an application log event. It's got the logger name, the name of the logger class that generated the message, say, in Java. And you see name type default in doc. And then the actual message, name type default in doc. So that's, and notice that the type of the message is union type or choice type between null and string. That means it can either be null or it can be a string. This is Avro's fairly goofy way of saying it's an optional attribute. I'm sorry to the Avro gods for saying that, but it's true. It is goofy. So, if I want to change my schema, will it mess others up? So we have determined, my colleague, actually, Gabriel Comeau, has determined a complete set of rules empirically for schema evolution, backward and forward compatibility. For example, you can add an optional field to your schema, but you can't change the type of any field. What's interesting about that, you might say, duh, that's no kidding. But what's interesting is that chains of compatible changes produce incompatible results. So if you remove an optional string called x, and then you add an optional int field called x, you have, in that chain, changed the type of the attribute x. So you can't tell, the moral of that story is you can't tell by pairwise comparisons that everything's going to be compatible. So we have a whole set of things that talks about what changes are compatible, and we can use this in reasoning about evolution. Is this schema compatible with three versions back? We have some conventions and best practices that we check for, and each schema is reviewed and approved by at least one human being. So a lot of the things that we look for are easily checked programmatically. Does everything have a doc string? Does everything have a default? But our conventions are useful doc comments are required to document every attribute. So if the attribute name is event type, the doc cannot say type of event, which is not useful. So that's one of the things that the humans check for. All attributes must have defaults. And unnecessary complexity is discouraged. I've been around databases for a while, and whenever you have a chance to build nested schemas, people tend to go nest crazy. If you can do it, why not? And some nesting is really valuable to express the data. Some of it is fine, but some is just completely unnecessary. And I quote a principle that I learned from my colleague Dave, who was in the audience, the Yagni principle. You ain't gonna need it. So more best practices. You can update data and schemas, but data must always match a schema in the registry or be traceable to such a schema. So that if you update the schema in flight or at rest, you have to make sure that the schema gets sent back to the registry. Schemas may be evolved at will, but non-compatible changes could be kept to a minimum. We can't tell people you can't do breaking changes, but you have to make sure that you mean it. And of course, you tell your consumers. And most importantly, the most important best practice is our philosophy of modular core subschema reuse. And this is really why we need our human reviewers. We have a bunch of core subschemas listed here that are common to many schemas, many of the things that we in Comcast like to talk about. And they give a common vocabulary to these data types. So that if somebody is talking about a device and talks about its MAC address, we say, I think you want to use our device core schema because we have its ID and its MAC address in there already, and we will be sure that you use the same device ID and MAC address and same capitalization, so that integrating down the road is simplified. And we're adding things as needed as our tendrils go out further into Comcast land. So to recap, Avro benefits. The benefits to the business are that you can integrate data. It makes it easier to integrate data across silos to make sure that the things across silos are integratable and that you understand what they mean so that you can answer the kind of business questions that you can't really ask any other way. And to data and schema governance, standardization, documentation, data lineage, compatibility, all that really good stuff. So that's the Avro section. Now, Avro is cool, but it's even cooler in the context of data governance with Apache Atlas. And the Apache Atlas instance that we chose was the Hortonworks one. As I said, I was here last year. I don't know if Andrew Ahn is here. I believe that's his name. But his talk was one of the ones that just pushed me over the edge about Atlas. It was just so cool. So to give you a little about our architecture. We have our platforms at the bottom, and we have user-facing solutions and products, and then our own, which can be used by other analytics teams, and then our own analytics, in-house analytics team, all using these platforms. So the platform architecture is like really any real-time architecture, Netflix, anybody. Can you see my cursor? No. So the data goes into a stream data collection, in our case Kafka, into then going left to CloudBridge, the green box, which is a connector and transformer platform, to Atlantic spins up distributed compute. It gets stored in the object store data lake. On the very top is the portal, which is really for people who are not that tech savvy to help them come into the system and understand it. And then across the top is our group, the Athene Governance and Security Group, which does data lineage discovery, schema creation, that sort of stuff. So why is it Athene? Because there are too darn many Athena projects out there. And Athene Noctua is the Linnaean name for the common name little owl. And this is the companion, or we might say the avatar, of Athena, the Greek goddess of wisdom, justice, and good governance. And that is an authentic late 5th century coin that we're looking at. Down the right side is an abbreviation for Athens. And it's a just gorgeous owl. Look at that. In 5th century BC. So I just showed it because it's gorgeous. We updated this for our team logo and brought a kind of grunge owl sensibility to our team logo. One of the people on my team, one of the programmers, has a BFA, so we let her loose on it. Anyway, so To refresh your memory, questions for data governance. Where can I find data? Data lineage questions, either from the producer or the consumer end, and data security. I'm not going to talk about security much because I don't really have time, but Ranger acting with Atlas allows you to tag things as, say, PII sensitive or PII, and control who gets to see them, excuse me. So Apache Atlas. We use it for data discovery lineages. It has a browser UI, REST API, Java API. Has synchronous messaging through the REST API, asynchronous messaging through Kafka. You can publish to a Kafka cluster that Atlas reads from. So we use it for schema registry as well as metadata. And the key things for us when we were choosing is it's open source and extensible. Yes. So the extensions that we've built for the schema registry, we've created new type definitions, an Avro schema, an Avro record, an Avro enum. I believe that those things are present in some Hortonworks product at this point, but that was actually partly due to the work that Vadim Vax and I did with this particular, with our version of the schema registry. We extended the Kafka topic type to include a lot of sizing parameters that we use to size our topics. We have reciprocal links between topics and schemas. Schema evolution, we have schema lineage processes. We store whether things are backward, forwards, or fully compatible. And we actually hacked the source code for better handling of JSON valued attributes. So for schema registry for data and ingest does what schema registry should do, well, except better. It allows browsing. You can find the schemas associated with a Kafka topic or no Kafka topic. If it's a batch, schema from batch, then we use the extension, the generalization of topic called subject. Schema lineage using Atlas processes, which I'm going to show soon. Evolution, compatibility. We can search for Kafka topics, and we have contact information on for people. And we also serve the vanilla use of a schema registry, which is we have a RESTful API for retrieving the fully expanded Avro schema for serialization and deserialization. So, okay, you can handle schemas. What about data sets? Well, for any data item in the community data store, so not just anybody's scratch space or whatever, but the community data store, we must be able to identify the Avro schema corresponding to it in the registry. So things like Avro binary files in S3 objects, we use S3 currently. Hive or Parquet tables derived from data, Avro data derived from those tables. Avro serialized JSON data in NoSQL. Anything, it has to be traced back to a schema so that we know what the heck it means. So for data lineage, we've built some extensions, and these are the really fun ones. We've created S3 objects that are also reciprocally linked to schemas. You'll see that in the demo. Hive tables and schemas are linked. And we also hacked the UI just to provide a link to our Slack channel. But most importantly, we created a Java library to facilitate creation and linking of entities and schemas using the asynchronous messaging capabilities of Atlas. So we can create an S3 pseudo-directory, an S3 object, and link it to the Avro schema, link it to the Kafka topic that the data came from, can update Kafka topic sizing. We can do a whole bunch of stuff to keep Atlas up to date beyond what Hortonworks offers in its product. It offers hooks to Hive and Scoop and HDFS and many other things probably that I'm not thinking of. But what's great about Apache Atlas from Hortonworks is that we can extend it to build our own hooks to send data back to Atlas. So, for example, how our platforms work together for data governance. So data comes in through what we call headwaters, the Kafka's cluster. It streams into our transformation platform, and it, creates an S3 object pseudodirectory from that data. And then it tells, using this library, tells Atlas that it created the pseudodirectory, that this pseudodirectory is linked to the Avro schema and also to the Kafka topic. Similarly, if we get batch data that goes into Hive tables, we not only use the hooks for telling Atlas that the Hive table has been created, but we link it to the schema also. That's our extension. And similarly with Parquet tables. So what I'm getting at here is that we built a library that can be used in, it's almost polymorphic, that can be used to inform Atlas of basic, of creation of entities and linking them to their Avro schemas. So this is where it gets good. This is the demo. So how do I get out of here? Box on my machine right here. So the first thing, really easy, text search with Solr. All right. XRE refers to oh no, are the demos getting, oh no, here we go. Whew. Okay. So these are all the entities that have to do with XRE. So let's look at the XRE errors Avro schema. So here it is, its description. So this is information on errors coming from the guide application on a set-top box. It has its Avro notation, the Avro notation used for SERDI, and boy does it have it. When it's pretty printed, it's pretty darn long. The reason I show you that is this is one of the ways the things we hacked. Because if you don't do that, you get that's what you get. So you just get, it's a string as far as Atlas knows, it's a string. So you get, I don't know if you can see, of course, that it's ugly and it's long and it's in your face, right? So there's no reason to have the SERDI schema, why we created this thing. And it works in any JSON valued attribute. So it doesn't have to be an Avro schema, it could be anything. You can just pop it up, open, pop it closed. Okay. The next thing to notice, instead of looking at that god-awful ugly representation, we represent it in hierarchical form. So we have, you might remember these core schemas and then some additional attributes. So so we can see at a top level what constitutes this schema. We can dig down into these core schemas and see that the device schema has a device ID, physical name, and also a network interfaces. It has its own embedded schema, network interfaces, which represents things like the MAC address, interface type, IP address. I think we've added some things since I did this sandbox. So the point is this is a much better way to get around and see what's going on in your schema than having to look at, and what vanilla schema registries generally do is they let you see the SERDI version, which is not very friendly. So let's see. Let's look at its associated entities, which is another addition we made. So this is the backlink from a schema to its data sets. So I'll go to its Kafka topic. And these partition counts, I think most of the number of events, maximum throughput, retention bytes, I think most of those are things we added. Some of them were already there, average message size. So these are the things that our algorithms use to calculate how many partitions and what the partition size will be in our cluster. And as you can see, it points to the Avro schema, so you got backward and forward. Okay, so we'll go back here and look at the schema lineage. So we've separated schema lineage and dataset lineage just to keep it from being too confusing. So here's the schema we're on, and this schema is a schema derived from it, and we have this process that describes how these things are related. And as you can see, it has compatibility. So this says same, that's the confluent ease for saying fully compatible. And then if somebody doesn't care about that, they just want to know, is it a breaking change? No, it is not. So there's some change that was made, but it's still fully compatible with the other one. So this guy also has associated entities. If I can, oh, sorry, wrong, I've got to go back. So that was the process between them, representing the lineage. This is the new schema again. And you can see that it has its own associated entities. So if I go to its Kafka topic, and the idea here is the original schema was embellished or enriched with, say, more customer information or something, and then produced this schema. So let's see. This Kafka topic, whoops, wrong one. Sorry, messed up my demo. Well, I'll jump to the chase then, since the gods seem to want me to. This is the entire lineage of the data that came into the first Kafka topic and ended up in all these various places. So the first schema, the XRE error schema, came in, the data came in here with that schema. It got processed into, this is the Hive table, XRE error table. It got stored in a pseudo directory, S3 object. Then it was embellished or enriched into the XRE errors 2 schema and resubmitted, republished to another Kafka topic. From there, the XRE errors 2 data was stored in an object, S3 object, and it was also republished to a Kinesis stream. So all of these green things, with the exception of the Hive table, are, well, the Kafka topic we extended. The other green things we created, we created ourselves. All these processes we created, and we have Java libraries that will not automatically, but can be called to at the point when you're going to create the S3 object, send that information asynchronously back to Kafka, saying, back to Atlas through Kafka, saying, I just built this thing. It came from this Kafka data. It had this Avro schema, so that everything's linked together. So that lineage-wise, if you're a producer and you want to know, okay, I sent my data in here, where did it go? What happened to it? You can see very clearly what happened to it and what kind of processing was done on it. If you're looking at data here in the data lake, you want to know, where did this data come from? Who produced it? What happened to it since it was originally, between the time it was originally ingested and the time that it was stored? Right there in pictorial form, and all of these are live and can be clicked to show interesting information about them. So that may be all I need to demo. I got my Got my cheat sheet here. Oh, I guess I wanted to show this DSL capability. It's, so you can, if you just want to know, say, this shows you that it can act like a vanilla schema registry. Looking for an Avro schema where the name is, well, you know the name. That's fine, but you can also project, which in relational terms, which for some reason is called select, just the Avro notation. Field. Okay. Extra space. Oh, thank you. It's really hard to see with these lights in your face. Okay, so I've just said I have this Avro schema. Its name is XRE errors. I want to know what its. I need its Avro schema because I want to deserialize my data. Here it is. And you wouldn't go to the UI to do this, of course. You would do this through the REST API. But everything I just did here is available through the REST API. And there are other things you can do through the REST API, too, that are very cool. Maybe I'll do one more, because I think I have time. So I can look for, well, I can do, you can do all kinds of cool stuff. But I'll look not for a Falcon feed. Kafka topic. Sorry. Sorry, I'm looking for an Avro schema. I want to know what are the Kafka topics related to an Avro schema. So, so I have a schema. Where can I publish it? I'm sorry. I'll just do this one. Kafka topic. Demo gods. Okay. This is the cool part. And then you say, okay, I'm looking at the associated entities. Remember, that's the array that links it to the data sets that it's linked to. So I want information on that. So I can alias it and then select its name. So, or if I didn't, oh my. Anybody see the problem there? Huh? Oh, thank you. As. Oh, as a, sorry. Put the S in the wrong place. Okay, so I don't know if anybody except database people care about this sort of thing, but you can alias this, basically a bunch of references within the Avro schema, and then ask for to retrieve an attribute of that. So I'm asking for all the associated entities that belong to XRE errors, and that's what I've got. So, the final thing I want to show is the other way we've hacked the UI is we added the Slack modal, I guess you call it, or icon, so that people can go to our Slack channel and yell at us or contact us that way. So, okay, I just got a couple more slides to sum up. So again, this is what I think makes Atlas really, really cool, that you can populate this and that you can visualize it. So what's next for us? Primarily, rather than making CloudBridge send all those messages to Atlas, in this picture, we want to build a service in between here, maybe using Genie or something that is the service that talks to Atlas and does things like create pseudo-directories and the like, so that poor old CloudBridge doesn't have to do it all itself, and so that other people wanting to create things that get sent to Atlas don't have to go through CloudBridge, more to the point. So more transforms, and we want to store more information about the transforms. So in summary, we use Avro for schema governance. It's our lingua franca for end-to-end metadata, and our best practices make it even stronger, we feel. And in terms of Atlas, our typedef extensions and our Java library make it more effective, make something that was effective even more effective. The challenges and solutions part I will breeze through. Basically, it's how do we get people to use Avro schemas? And nobody wants to be governed. It slows, developers feel like they get slowed down. How do we get them to not feel that way? Well, one way is that we had a top-down mandate, but another way is that when people started using it, they realized that it's their best friend, because if data comes through that isn't conformant to the schema, they'll find out about it. And I actually got a letter from one of the chief critics one time saying, Avro to the rescue! So he was a convert. Also, the analysts love it because they know that it's going to make their lives easier, and they won't have to spend 70% of their time futzing with data. They'll be able to spend maybe 30% of their time futzing with data and the other 70 doing what they should be doing, which is analysis and machine learning. Okay, so so the problem is creating these conformance schemas is not really trivial. So we're building UIs that enable this to be done very easily, and maybe someday I'll get to talk about that here, but we've just released them, and they look like they're going to be very popular. And the challenge to finding data governance tooling, the answer was Atlas. So just wanted to recognize my collaborators, my team. I'll go from top to bottom, left to right. Nolan, Taylor, Jack, Ajay, Mike, or on my team at Comcast, and who could not be encouraged and inspired by such a beaming, lovely group of people. And Vadim Vax, who's a senior solutions architect with Hortonworks, was my partner in designing a lot of this stuff. He was shy and didn't want his picture there, so I just put the Hortonworks logo, but he really deserves to be recognized also. So I think that's it. Yeah, thank you. Thank you very much. So I have no idea what time it is. Is there time for questions? Okay.
So you described a lot. How do you prevent people from just bypassing you? This is opt-in.
Well, that's a good question. And that's why, well, right now, nobody can put stuff into the data lake if they don't put it through the CloudBridge platform. Clearly, that's too limiting. And that's why we want to build that service that anybody can use. But basically, we don't let people write to the data lake directly. We make them write through a service that sends that stuff back. So it's a little bit, so this goes against the standard idea of a data lake as something where everybody throws everything in and then you worry about it later. You know, no, we're not doing that. We're from the very beginning trying to make it make sense and exert some control to make sure that nobody can subvert it. No, that's it? Okay, thank you very much, everybody.